5-week test day. Student A, and Tristan, maybe just the middle row. Sorry, keep making you get up. Student A took salt water, NaClAq, and evaporated the water, right? Because in here, there's NaCl solid, and H2O liquid. So someone tell me, if I evaporate the water and I'm student A, what's left in the beaker? If I evaporate the water, I shouldn't have drawn that, right? So what's in here? Just what? Salt. So we have a bunch of salt here on the bottom, right? NaCl solid. So if we have H2O gas up here and salt here, and in the original solution I have H2O and NaCl, did anything change? No. Physical change because the composition stayed the same of the salt and the water. You didn't have to write that because I didn't word the question very well. What I should have written is state whether student A or student B is physical or chemical change, and then support your answer. That's what I should have put as the question. So you could say A was physical, B is chemical, but then you would have to say why if I said support. So if you just stated A was physical, B was chemical, you got credit. I had to give credit because of the way I worded it. Some of you went on to explain, and that's good, that's better, but you didn't have to, right? So that's on me. I wish I worded it better. And then student B took electricity and split water, right? So collected hydrogen and oxygen. That's definitely chemical because these two are elements. That's a compound, very different properties, liquid, clear, colorless gases, flammable, both of them. You know, like water's not flammable, obviously it puts fires out. So very different properties, that's a chemical process. All right, and that's, what's that called? Using electricity to separate compounds. Electrolysis, right, okay. 32, or 32. And really, try and stay with me here. I know it's not super exciting, but it's really important, especially this question. I'm going to spend a little time on this question. So, what's the biggest mistake students make with this type of question? What do you think the first thing they do, maybe you did it, when you flipped over the page and you get to this page, what's the first thing you look at, do you think, for most students? What's the first thing they do? Okay, maybe they read the data table. I don't think that's the first thing, but maybe it is.
Read the question.
Yeah, a lot of kids will go right to the question because they don't want to, and this is how I thought when I was in high school. I still remember this about myself. I would go right to the question and see if I could just answer it. Because I was a pretty good student, I had pretty good grades, I thought I was pretty smart. So I thought, why do I need to read all this stuff if I just know the answer anyway? Didn't always work out for me, so I'm on the other end now, I'm the teacher, I'm trying to give you guys advice. Don't just go right to this question and then answer it. You can go right to the question. Identify a process used to separate the components of natural gas. But then after you read the question, what should you do? Now go back to the data table and then the writing above it. That stuff isn't on the page just for fun. It's not like, hey, here's the boiling points of 4 gases, just for your information. Now, go ahead, continue to take the test that has nothing to do with this data table. Okay, obviously it's there for you to use it, and if you read the paragraph above it, which, now I'm on the other side as a teacher, that's what you should do. Start at the top of the page and move through the page that way. Don't just go right to the middle where the questions are. So you go to the top. Natural gas is a mixture that includes butane, ethane, methane, and propane. This next sentence is kind of important. Differences in boiling points can be used to separate the components of natural gas. Why is that a fairly important sentence? That's literally the answer to 32. You don't even have to understand anything about the question. You just have to be able to read. Okay? And I'm not trying to be a jerk, but I'm showing you how easy some questions are, especially if you got it wrong. You're probably like, why didn't I read that better? Or why didn't I think of that? Or why didn't I do that? Okay, the reason we give tests isn't to punish you, make you feel bad. It's to practice for the end of the year and to see how well you're retaining and learning this stuff, right? So this is good practice. So if you screwed this question up because you really didn't read very well when you were taking it, lesson learned. Next time we have a test or quiz and there's a reading passage, make sure you go back and read it. The answer's right there. So for 32, all you would have to write is use the difference in boiling points. That's what you could write. Use the differences in boiling points. Or you could actually just write one word, boiling, and I'd give you credit because the process is boiling. Okay? So if you got it wrong because you didn't reread it, and this morning a couple kids admitted, they're like, yeah, I didn't even look above the chart, or I didn't even see that, right? So that's why we do this, right? These are Regents questions. Let's get better at it throughout the year.
There's a check mark, right?
Is a check mark right? Yeah, -1 would be wrong.
Okay.
There's another word that isn't on that page anywhere that is the right answer.
Distillation.
Distillation, right, which is using boiling points to separate. That's the exact, that second sentence is the same thing as distillation. That's the definition of it. So, again, I'm going to go on and on about this question here. Let's say you have 4 gases in this box. You have propane, butane, methane, and ethane. Okay. Tristan, can you actually boil them? If this box was sitting on my desk and I had 4 gases filling up the box, could we boil it? No. Why? It's already boiled. Anything that's a gas is above its boiling point. So oxygen in this room is already above its boiling point. Everybody believe me or sort of with me here? So this room is about 23 degrees Celsius, probably. If we drop the temperature in this room, again, this box we're imagining is sitting right here, to 0 degrees, okay? We'd be really cold. Would any of them change phase? Look at the data table. I'm relating this to the data table. When would one of them start to? Right, -0.5 would be the first gas to do what? Condense, liquefy. Okay, so where are we? Which one is it? Right, butane now would be down here, okay, as a liquid. And I know this drawing is really bad, but I don't really want to take time to make it really accurate. I'm just trying to explain the concept. So instead of a gas, it's going to be down here as a liquid. Maybe we have a little valve, liquid comes out, we catch it in a container. Now butane's not in the mixture. So we just separated butane. Congratulations. Now we got to separate the rest of them. What do we keep doing? Lowering the temp even more. Who's next? Right, so propane, right? So now this one would be out the valve. What's next? That would be ethane is next. That goes out the valve, so it's liquefied. And last would be -161.6 would be methane. Methane would condense last.
You said.
Oh.
Saying, I haven't heard.
Right.
I'm confused.
Sure. Okay. So -161.6. That is the lowest temperature that these gases need to be at as far as separating them. So butane first, then propane, ethane, methane. So what's the real way to answer this question? I just told you I'd give you credit for distillation and boiling, but that really makes absolutely no sense because they've already been boiled. But because the Regents gave you the boiling points as data, every teacher in the state will give their kids credit if they say use boiling points. That's what they want you to say. It doesn't make sense. So what should you say? Not distillation is using boiling points. I mean, you're not wrong, but it's not worded very well. So what did we do? What is this? What did I just do here? What was this example? We're cooling it so these, they don't boil, they are
Wait, I have a question.
condensing or liquefying, right? So hold on 1 second, sorry D. So how I would answer it as me, the teacher, I would write for 32, I would lower the temperature until the gases condensed at different temperatures. That's the best way to answer that. Because given the boiling points, I know when they condense. So I would say lower the temperature until they start to condense, and that's how you could separate it. So that's actually a really hard question, and why I spent, 5-10 minutes on that. Because it's, if you can understand everything I just said and the technique of how to answer these questions, you can do any question like this on any topic. This just happens to be on gases and boiling points. Yeah.
Number 33, is that the answer? pretty much.
Well, 33 is a whole nother ball game here. Some of you might get angry with me. Are any of you hungry?
Yeah.
Yeah? No? Well, then you won't be hangry.
I just ate lunch.
Get it, Cody?
What?
I said hangry.
Hungry.
Hungry and angry. I get that all the time. Anybody else?
I do.
Oh, yeah.
Yeah, I'm like, if I get real hungry or miss a meal for something catastrophic has to happen for me to miss a meal, I am miserable. Okay, here's why some of you are going to get angry at me. If you wrote your list, so we're on 33, if you wrote your list, we'll say up and down, vertical here. So if you wrote methane, ethane, propane, butane, or if you wrote butane, propane, ethane, or methane. Some of you in here, I think, wrote that, maybe the other class. I didn't give you credit unless you numbered them, and even if you numbered them, I'm still a little confused. So some did this. It wants to know, out of the four gases, who has the weakest forces of attraction, and who has the strongest. So lowest forces, or highest, or weakest, strongest. So the problem I have with this, if you can think of it from my perspective or someone grading this, I'm not confident that this is the weakest or strongest. I don't know what your number 1 means or your number 4. So you could say this is the weakest and this is the strongest, or that's the strongest and that's the weakest. The same thing goes for this.
What if we wrote it like this?
The only way to really get these questions right and make it easier for teachers to grade, because when it comes down to grading, I can't grade yours. I bring your test to Cobleskill, and there's like 2 or 3 teachers there. They grade your test, and then I grade theirs, right? So I can't grade what you guys write. So you want to make their life a lot easier. So don't do that. Any question the rest of the year with increasing, decreasing, write it left to right, because that's how we write in our culture. Okay, we write left to right. So methane would be first, then ethane, then propane, then butane. So methane would have the weakest, and then these would have the strongest. So methane's particles are very far apart, really weak, -161. Butane particles are much closer together, stronger attraction, -0.5. It takes way more energy to boil butane than methane. Okay, think of water. Water boils at 100. Well, some other substances boil at 200. That's twice as much energy, essentially. You can argue the Kelvin thing, but the point is it has to be a lot hotter. So bromine, yeah. Butane, much higher than methane, and then these two are in the middle. This is -88, this is -41. So that's the weakest. Ethane's a little stronger than methane. Propane's stronger than ethane, and butane's the strongest of them all because it has the highest boiling point. Okay? This boils at like thousands of degrees. Thousands. Okay? This boils below 0. So when I'm comparing those two, this is way stronger. It's a solid. It's metal. Way stronger for forces. I'm just really trying to hammer home the concept. 1, how to get it right, and 2, how to write it. Because there's always 2 things at play when you're taking a test. How to take the test, and then the content. This question's both. Please write left to right. Don't give me up and down. It's too confusing. I can't say, oh, well, they know that. I think they know what they mean. I really need to spell it out for me. Okay? So weakest to strongest, left to right, because that's kind of naturally how we write. So if you did the vertical thing and you think you get a point back, maybe you can fight, for your case there. So if you want to talk to me, come talk to me. All right, 34. 34. How many particles should be in the box? 12. Very good. Why? It says 6 in each phase. So if you have a box, first of all, there's 2 phases. Some students only put in 1 phase. What 2 phases? You got to go back up and do the reading. It says, the last sentence, at 20 degrees, this tank contains both CO2 gas and CO2 liquid. Liquid would be down here, okay? Fairly close together, a little bit jumbled, right? I'm gonna cheat and only put 4 just to save time. So there's a liquid, and then the gas would be spread out, okay, up at the top. So that's what I'm looking for here, something like that. And there were a couple tests where the student didn't, it sounds so formal, where the student, one of you guys, one of the other kids in class 2 there, period 2, didn't use the key. That frustrated me. You gotta use the key. They give you a key, use it. Don't just make up your own molecule, okay? Liquid, gas, in the same container. Then I had some students draw another box, and they put the liquid in one box and the gas in the other. Again, reread the question. You're not reading carefully. It says you must include 6 molecules in each phase. So one box, both phases. If you draw another box on a Regents, you're doing something wrong. They give you what you need, right? So just keep that in mind. 35.
Oh wait, I have a question.
Yes.
You wrote S or L on mine. Is it right or wrong?
Is there a -1 or a check?
Neither.
There's no -1, then you're fine.
Okay.
But some of you, not just you, others, it looked like your liquid was a solid. Be careful with that. Okay, I gave it to you probably, but just be careful. All right, here we go. So we got a flask here, and in the bottom of the flask you have a chunk of dry ice, solid CO2, and it's at -78, right? Yeah. On top, you got a balloon. It's deflated or inflated. Which one? It doesn't matter. Here's your balloon. Okay. So what's happening here is this is subliming. That's the answer to 36. Subliming or sublimation, and the gas is going into the balloon. Okay. What's the temperature of the air? 21. So up here, the air is 21 degrees. So the answer to 35 is very straightforward. The
Air to dry.
heat flows from the air to the dry ice. That's the answer. The heat flows from the air up here into the block of dry ice. Why? Hot to not, right? Warm, 21 down to -78. So heat goes from the air to the dry ice. If you wrote the cold goes to the air, please get that out of your head. Cold doesn't move, cold doesn't exist. It just has less heat. That's the better way to say it. So the warm heat goes to where there's less heat. Okay? Cold doesn't move. 36, sublimation, solid to gas. 37, who has particle arrangement circled? Raquel, sit up. Like up, sit up. Put your feet flat, wake up, pay attention. Don't lean on your hand. Thank you. Bridget, if you have particle arrangement circled, okay, a lot of you, a lot in period 2 as well. All right. So, you have a block of CO2, and then you have the sublimation, the air up here, okay? Everybody here, I think, got this part right. This has low entropy, this has high entropy. But you're not using the terms. You have to talk about particle arrangement. What does that mean? What's particle arrangement, Maddie?
It's like how closely together.
How close the particles are. Good. What's the problem with these big, wide mouth bottles?
Yeah.
Low entropy. How are the particles arranged? Down here. Very close. You get full credit if you say that. Gas, high entropy. How are they arranged? Spread out, moving around. You get full credit. If you just tell me low entropy here, high entropy here, I can't give you credit. You have to use the terms it says to use. Again, practicing all year using terms on tests. When you get to the Regents, it'll be automatic. Use the terms. Okay? Anyone get full credit on this one? Bree, can you read what you wrote?
It said CO2 molecules in dry ice are tightly compacted and have less entropy, while CO2 molecules in an inflated balloon are spaced out so they have more entropy.
Yeah, I can't even write that better. You wrote that better than I would. Good job. So the dry ice particles are tightly packed, low entropy. Gas, they're spread out, high entropy. Very good. Okay, and 38. And then we're done for today. And then Raquel, you can go back to sleep in whatever class you have next.
Yeah.
Are you asleep still, or are you with us? Good. All right. Don't complain about 38 saying, I don't know what ethanol is. Why? If you read the question, you can figure it out. If you don't know this is glucose, at this point, after biology, after a couple months of chem, I've already talked about it, you're in trouble. That's glucose. You know that's CO2. There's only one thing left. That has to be the ethanol. Because I've had kids in the past argue with me. Well, we didn't learn that. You didn't teach us ethanol. That's kind of irrelevant. Here's why. It says you have 270 grams of glucose, 270. It says you have 132 grams of CO2. This is ethanol. How many grams of ethanol? Conservation of mass. Eyes up here. This is equal to this plus this, like scales. Products must equal reactants as far as mass. So 270 minus 132 is 138, and that is the answer to the question mark. That's how you do that problem. If you got confused with the twos or you just forgot how to do this, that's fine. We're learning right now, hopefully, if we made mistakes, how to not make that mistake again. All right, and that's it. I know it wasn't super exciting class, but it was definitely needed or worthwhile going over that. Have a good weekend.
Do we have to come see you still?
Yes, because I got to go over the multiple choice.